This is the second video in the introduction to exponential functions. In this one, I'm actually going to do 3 examples with you to graph it. Whenever we do these, what I'm going to want you to get used to doing is every time you graph, I want you to always include the horizontal asymptote because that's what helps you level off. You should also include at least 3 points. You're welcome to include more, but at the very least, you need the y-intercept. That'll take you about a second to get because you just look at the equation and get it. You'll need to plug in 1 and -1 into the function, and that will get you a good idea of how quickly this thing is growing or decaying, if it's a more wide graph or a more steep graph. At that point, if you're still not happy with how accurate your graph is going to be and you want to be more accurate, you could include like 2 comma something or -2 comma something, just so you know. Let's start off with 3 times 2 to the x minus 2. The way that I'm going to want you to graph these at first is to graph the non-shift and then the shifted. So by that, I mean what we're going to graph first is y equals 3 times 2 to the x. What we're going to graph next is 3 times 2 to the x minus 2. Because what the minus 2 does is it moves it down 2 units. So let's go ahead and do 3 times 2 to the x first. So that would have a horizontal asymptote of 0, like this. Again, I'm ignoring the minus 2 right now. All I'm doing is graphing this. The y-intercept is 3, 0. Let's plug in 1 real quick. So that'd be 2 to the first, which is 2, times 3, which is 6. Now let's plug in -1. That'd be 2 to the -1. 2 to the -1. Let's see, that's a half. A half times 3 is 3 halves, or 1.5. So that means I have 0, 3, 1, 6, and -1, 1.5. So go ahead and plot this with me in your notebooks. Just give yourself a quick XY plane here and graph it. Unless you have graph paper, then use graph paper. I'm going to graph this in a dotted line because this isn't my actual graph that I'm trying to graph. This is like the intermediate step. All right, so I'm pretty happy with that graph. Looks all right. Now what I'm going to do is shift this thing down 2 because that's what the -2 means. Remember how I said C would always be your horizontal asymptote? If I take my horizontal asymptote as 0 and move it down 2, now it's -2, which is exactly what C is. So now what we're going to do is take our 3 points and just move them down 2 units. So 1.5 goes down 2 units and is -0.5. And what are you doing, computer? 3 goes down 2 units, becomes 1. 6 moves down 2 units, becomes 4. And this is our actual graph that we want. So make sure on your paper you have both of these graphs do the dotted intermediate step and the final one. All right, cool. Let's do another one. For the next one, I'm going to go ahead and do 2 times 1/2 to the x plus 3. So make yourself a new graph. And this time our intermediate step will just be 2 times 1/2 to the x. My final graph will include the x plus 3. All that the plus 3 is going to do is go left 3 units. You do the opposite of what the sign says whenever it's with the x in the exponent. Okay, so our horizontal asymptote for my original is going to be 0, like that. And the y-intercept is 2. Let's plug in 1 and see what we get. 1/2 to the 1 is a half. A half times 2 is 1. Now let's plug in -1. A half to the -1. You got to be good at doing your negative exponents. Put the 2 up top to make it positive. That'd be 2 to the +1. Okay, so that's 2. 2 times 2 is 4. I'm anticipating this thing should look like decay if I'm going to be doing it right. And if I plot my points, I can see this thing definitely does look like decay here. Very obvious that's going to be decay. And I'm leveling off here as I go. So there's my intermediate step. So let's do our final step now. All I'm going to do is move everything left 3. So now think about this. If I take a horizontal line and go left 3, is that going to change my horizontal asymptote? The answer is no, it's still going to be y equals 0. So let's go 1, 2, 3, 1, 2, 3, and 1, 2, 3. There's our final function, shifted left 3 units. I'm leveling off at the horizontal asymptote. I'm going all the way to the right and all the way to the left, putting arrows on each graph. All right, so make sure you have that one all set. Let's do one more, and this time let's do y equals negative 4 to the x plus 1 plus 4. Oh my goodness, there's a lot going on here. One thing you should notice right away is that negative right there is a reflection, obviously. And the way that this is a reflection is this is going to reflect over the x-axis because it's out front. This is going to be moving left 1, and this is going to be moving up 4. So here's what I'm going to do here. I'm going to graph negative 4 to the x first, and then I'm going to graph negative 4 to the x plus 1 plus 4. You should always consider the reflection first and then shift the reflection. So I already know that 4 to the x would look something like that, but I'm not interested in that. I just basically want the negative of that. So negative 4 to the x has a horizontal asymptote of y equals 0. At 0, if I plug 0 in, negative 4 to the 0 would be negative 1, because 4 to the 0 is 1. If I plug in positive 1, that'd be 4 to the first power, which is 4. The negative just makes it negative 4. If I plug in negative 1 in, so that'd be 4 to the negative 1. 4 to the negative 1 is a fourth. And then I put the negative to it, so it's negative fourth. So let's see, 0, negative 1, 1, comma, negative 4, and negative 1, negative fourth. So all that this is a reflection over the x-axis of what 4 to the x would look like. So that point keeps going away. All right, there we go. Pretty steep decay right here, which we're expecting. Now let's go ahead and consider my left, right, and up 4. So I'm going to take this point and go left 1 and up 1, 2, 3, 4. Okay, now take this point, the y-intercept. Left 1, up 1, 2, 3, 4. And come on, stay there. Now let's do this point. Left 1 and up 1, 2, 3, 4, right through the origin. And we cannot forget our wonderful horizontal asymptote, which is going to be our C value of 4. Shift 0 up 4 units. And you're going to be right here, like that, and just do a nice smooth curve, decaying quickly, going down. Make sure it levels off near the HA. Okay, and just to double check, I did graph this here. This is negative 4 to the x plus 1 plus 4. If you get rid of the negative, it's just facing upwards. So the negative just makes it a downward reflection. All right, so with those 3 examples, you should be good to go, and we will practice in class. I'll see you later.